Hello and welcome to this new C programming tutorial. This is part 6 on how to program in C. Okay, so in the previous tutorial we actually created a useful program that enables us to get input from the user and print some output to the screen. In this tutorial we will learn about pointers and we will learn how to print cool patterns to the screen. If you want, you can save this code for your learning purposes, but I will delete this in order for me to explain this better. Okay, I will delete everything and I will write int main. Okay, and we'll return 0. Okay, so what is a pointer? So we will learn pointers. A pointer is a variable in C, is a way to access an address. Okay, so a pointer is a kind of a variable that stores a memory location of something else, like another variable, right? So we will learn how these addresses or these pointers work. Okay, if I define int n equals 2, okay, I am creating a new variable of type integer and I am initializing it to the value 2. But this variable is stored somewhere in memory, okay? If we want to know where the variable is stored, we will do the following. So, if we want to know and to print the variable, we already know how to do that. We call printf, double quotes, percent sign, v, new line, and we will pass the name of the variable, which in this case is n. So we already know how this works, right? If we compile this and if we run this, we print number 2, okay? So we print number 2, which is exactly what we expect. But what if we want to print the location of the n variable? So to print the location of the n variable, we will do the following. We're gonna say printf address of n, okay, and we will enter percent x to specify a hexadecimal value, and we will pass an ampersand, this symbol right here, and the variable name, which is n. Which this means if we put an ampersand before a variable, this means please get the address in which this variable is stored. Okay, so let's compile, and here we have an unsigned int. So it says format specifies type unsigned int, but the argument has type int pointer. Okay, since we're just printing a variable, we will ignore this, but we forgot to add a new line, so a new line right here. So if we compile this and run, we can see here that address of n is dd67ef8. Okay, but we can also use, so this is kind of a pointer, is we can now store this address in a variable. Okay, to do that we create an int pointer, we will call address of n. Okay, we will set this to the address of n. Okay, So now if we, instead of printing this variable, we print a pointer right here, we can print the pointer. So what happens if we pass the pointer address of n? Okay, let's check. So we have a different address, as you can see. But now we can dereference a pointer. So what does dereferencing means? Well, dereferencing means give me the value at this location. Okay, so previously we used this sign to get the location of this value, but now we have the location and we want to get the value at that location. Okay, so we will change from x to d because we will print the value of that location, and to dereference we will put an asterisk before the pointer name, which this asterisk means give me the value at this address of n location. Okay, so remember, this address of n variable stores a location, an address. So I'm saying give me the value of this address. Okay, so if I compile this and if I run this, as you can see here we have 2. Of course it still says address of n, but here should say value at address of n. Okay, so we do it again. So the value at address of n is 2. So this is basically how we can do this. So this is how a pointer works. First, we can get the address of the pointer of a variable and store it in a pointer. Okay. So a pointer is a variable whose value is the address of another variable. Okay. So pointers, I will write it here, are variables whose value is the address of another variable. Okay, so that's what pointers are variables that point to another variable. Okay, so we learned how to use pointers, how to dereference pointers, and now we can do the following. For example, let me create a character pointer, as we made, you may remember from previous tutorials. So you say char space asterisk means define a character pointer, and I will call it string. Okay, and I can initialize this to hello world. Okay, so that's how we create a string, and this pointer is pointing to the first element of this definition right here. So we can now print this, print f %s new line string. Okay, if we print this, it prints hello world. Okay, but remember, this is a character pointer. Okay, we can also print one character. So how can we print only one character? So we're gonna do another printf. Printf %c to print a character, new line, and what we will print will be a string at 0. Okay, so what this means is print the first character of the string, which is h. Okay, so let's see if it works. And as you can see here, we have an h printed right here. Now this is a character pointer that points to the first element of the character. If we change this to 1, it will print the second element of the string, which is E. Okay, and we can keep doing that as long as we want. But what happens? So this char pointer stores an address. Okay, so this stores an address. So what if I want to print the address of it? So if I want to print the address, maybe I can make something like %v if we want to print it, or hex to print it in hexadecimal, and we will print the address of string. Okay, so if we print the address of the string, we have this address right here, but here we have a kind of a wording right here. Oh, okay, so we don't, oops, I did it wrong. So we have to put, I did the opposite. So here is the new line, and instead of C, we will put hex. We can also put an unsigned, so it also will work there if we don't want to print in hex. Okay. So as you can see, let me run. This is the address in decimal notation, right? Okay, so, and now what we want to do is print the address. So we say address of string, okay? And this is the address of the string, right? And this is the address of the string, right? Okay, so this is the address where this pointer is located. Okay, so this pointer is also stored in an address. Okay, so what we do here is that when we say ampersand string again, this is meaning give me the address of string, okay, which is on itself a pointer to another place. So basically this gets the place in which a string is saved, and a string gets the place or contains the place where the hello world string is saved, right? So that was a string. And now what happens if we, so the current value of a string is this. We can increment the pointer of string to point to the next element, right? Okay, so if we get and say give me a string is a number, right? A string can also be printed as a number, which is the address of the thing. Okay, so we will print a string, we will increment string, so we're gonna say string plus plus, okay, and we will print it again. We're gonna say print f open parenthesis %u \n string. Okay, so we are printing the current value of a string. Okay, then we're incrementing it and printing the next value. Okay, so here you can see that the current value that is stored on a string is this memory location, which is 4,195,980. And if we increment 1, then we have here the result. Now, why I'm doing this? Well, because what happens if I print the string? So basically, I'll do the same right here. I'll copy it again just below it. But instead of printing the value of it, I will tell it to print the string that actually it's contained there. So let's check. And as you can see, the value, the content, and the incremented pointer. Now, after we have incremented the pointer, we will do the same again here. Okay, so we have incremented the string pointer. Okay, so if we do this, we have this. So first we have this value, okay, which is where hello world is located. Then we have the content of that location, which is hello world. Then we increment the pointer. So we increment the address we are pointing to. And then it is printing only this, not the H, because we incremented one cell and we are now pointing to E instead of H. Okay, so this is basically how this pointer works. Now, this was illustrated creating the strings. Okay, now let's create an array. Okay, let's create an array. So say maybe char. And I told you in this tutorial we will start learning how to display some cool patterns on the screen, right? So I'm gonna say I call this frame because we will display frames, okay? So, and this is an array that has some size, right? So the size of this array would be maybe a squared value, for example, 5 squared or 6 squared or something like that. So if you want to compute it programmatically, you're gonna say first you're gonna say const int screen resolution, and it will set it to maybe 10, which means 10 by 10 pixels. Okay, so it will be 10 times 10. Okay, and now inside frame I've set it to screen resolution. So we will use characters as our pixels, and in this case that will be displayed on a frame of 10 by 10 pixels. Okay, so that's basically how we initialize this. And now we want to define our two really states or possible states of pixels. So you can say constant character. I will define it as pixel on, and I have to do it in single quotes. Maybe I will define it as an asterisk. So you can use anything you want here, a letter, whatever. I will define it as an asterisk, and I will also define const char pixel off, and I will define it as a space. Okay, so we now have definitions, we have our frame. Now we have to fill our frame with our contents. So we're gonna create a for loop. So you can say for int I equals 0, okay, I less than screen resolution, okay, and we'll set this to I++, okay. We open the for loop and we will say frame at I equals pixel on. If we just want to fill the frame with pixels, we do this. And after we've done this, we can print our pixels. We can say printf %s to print the strings, and we'll print, of course, let me see, we'll print frame. Okay, so let's check how it works. And as you can see, it prints 100 asterisks. Okay, so we have our frame right there, but we want it to print in a squared way, kind of in a display. So we want to check right here, and maybe we want to print every character as we fill it on the screen, on the frame, right? Okay, so it will change this to character, and we will put this printf after we set it to pixel on right here, and we will set this, we will print frame at I, okay, if we can do this. But we can also create another for loop, okay, so maybe we will create another for loop. So we will put this here, and we will say for, in order for us to have it to be easier to understand what's going on here, so int I equals 0, I less than screen resolution, and I plus plus. Okay, so the first for loop is used to fill the screen, and the second for loop to fill the frame, and the second for loop is used to display the frame into the screen. Okay, so awesome. So we have filled the screen right here, and here we'll be displaying it. Okay, but I told you we want the screen to look like a real screen, right? So 10 by 10, not just 100 one after the other. So to do this, we will check the following. We say if I modulus 10, in this case, equals 0, it means we have reached a new line. So we have to print a new line. So you'll say print f, and we'll just put a new line. Okay, so now let's run it to see how it performs, and here's what we have. Okay, so we have all of these right here, and we're printing our new line. Now, as you can see on the first line, we just print 1. Why do we print 1? Because that's pointer 0, right? So we don't really want to do it with 10, so we maybe want to do it with 9, because 9 means 10th element. Oops. What did I did wrong? Let me see. I didn't compile it, did I? So we still have this problem. Let me check what's going on. Oh, maybe we have to print after we check it, right? So yeah, I think we will have to print these after we check it. Okay, so there we have our thing right here, and I think this will be back to 10 if I'm not wrong. Let me see. And yeah, there we have our frame. Okay, then we have our frame, and after printing all of these, we have to print a new line. So we're gonna say copy this here, I print a new line right here, and to make these more ordered, what we will do here, I will enter an extra space after printing the character. So I will run it again and check. As you can see, it looks a lot nicer. Okay, looks a lot nicer. And that's basically how our frame will look like. Okay, so this is a basic screen. If we want, we can increase the number of pixels. So we are now on 10 by 10, right? We can maybe increase it to 14 or something. So go say 14, and here also 14, and also here 14. So let's now compile and run, and this is our 14 by 14 frame. Okay, in order for us to visualize it better. So that's where we want it, but now we will change the way we feel the screen. We feel the frame, right? Okay, how do we change it? Oh, for example, now we are just putting every pixel to pixel on, right? But now let's create some patterns right here. For example, we will use the modulus operator. We learned how to use it in previous tutorials, and just to remember you, the modulus operator returns the remainder of a division. We have already used it right here. So this is modulus operator. So it says divide I by 14, and if it's returned 0, it means we are on a place in the line where the line ends. So we will do something like that here. So you go and say if I modulus 2 equals 0 and else. Okay, so what this means, basically it means if we divide a number by 2 and we have no remainder, we will set the pixel to pixel on. Otherwise, we will set frame at I, we will set it to pixel off. Okay, so if we run this, we have a very basic pattern that say one on, one off, one on, one off, one on, one off. We can keep going with this and maybe change this when it's divisible by 3, right? So if it's divisible by 3, we will set it to on, otherwise it will be set to off. Okay, and here you can see it. So 0 by 3 it returns 0, it's divisible by 3. 1 and 2 are not divisible by 3, so they are off. 3 is divisible by 3. 4 and 5 are not divisible by 3, but 6 is divisible. So 7 and 8 are not, but 9 is divisible, and so on. We keep going, and here we have this cool pattern. Only checking if a number is divisible by 3, we now can see that this new cool pattern has emerged. Okay? So we can do lots of different crazy checks. So we are checking if it's divisible by 3. And now we'll check if it's not divisible by 3, we will check if maybe it is divisible by something else, maybe by 4, right? So if it is divisible, oops, what I'm doing here. So if it's divisible by 4, oops, okay, we will also set pixel pixel on, otherwise we will set to off. Oops, else if, sorry, there's an if missing right here. So else frame at index I will be set to pixel off. Okay, awesome. So if we compile this and run it again, here we have a more complex pattern, as you can see. Okay, so this is basically how we can do it. So again, 0 is divisible by everything, right? So then we have 3 and 4. We have 6, 7 is not, and so 8 is divisible by 4, and 9 is divisible by 3. Okay, so as you can see, we have this kind of a pattern too. We can kind of start to write. So maybe to look the pattern in a better way, we will increase the number of pixels. So we're gonna go and increase it to 20. Would 20 be too much? Let's see. So 20, of course, depends on the size of your screen, but don't forget to change 20 here too. We can also create a variable if we want to change it several times. So as you can see, here is a 20 by 20 pixels. So this has 400 pixels on it. Okay. So we can keep doing this and keep going. And maybe we want to print a new frame, right? We want to print more than one frame at a time. Okay. So to do that, we will maybe call method, or we can actually use kind of an old way in which C used to do stuff. So it's not really encouraged to do this because, well, for some programs anyway, it is harder to know the control flow operations, but for this program, since it's very simple, we can do it. So we're gonna say go to and say print frame. What this means is jump to print frame, but we haven't defined print frame. So we will go and define print frame up here, just before the for loop. So you can say print frame, and we'll end with a colon. Okay, so what this will do it will create an infinite loop, right? So it will create an infinite loop, but this will print so fast. So the computer is so fast, we don't want it to print that fast. We may want to wait 1 second before printing the next one. To sleep or to wait, we will include the following library, the unistd.h, okay? And this means, and we will put, before we go and say go to print frame, I'll say sleep for 1 second, okay? Otherwise this will print like crazy, very fast. So let's run it. And here we have how it's printing every time a new frame. Maybe we want to change the frame kind of values, right? So we want to define right here. So here we're gonna define int first value, we will set it to 3, and we also define int second value, we will set it to 4. Okay, and here instead of 3, we will change it with first value, and here the 4 right here, we will change it with second value. Okay, and after we complete this first for loop, we're gonna say first value plus plus, and we're gonna also say second value plus plus. So now we will run it to close these program loop. We will press Ctrl C, and now we will compile it again and run it again. And as you can see, every time it is printing a new cool pattern. Okay, you can leave it going for some time, and you will find very cool patterns. You can increase the pixel size, the pixel count, and so on. So that's it for this video. I hope you enjoyed it, and I see you in the next one. Bye.